9.3. Test data. All programs should be tested to detect errors, if any. Of course, invariably there are errors whenever you do a program. Very rarely you will get a program first time correct. There'll be errors. So you have to do testing. Before a whole system is tested, uh, each subsystem is tested separately. Now recall what we learned about subsystem. There's a full system or a task or a problem. Then we have the sub problem, sub tasks or sub. Each subsystem is tested separately. But to test the system thoroughly, different sets of data are used several times. Not only once, several times. And better different sets of test data. The set of test data used in the activity above was 7 and 18. Can you remember? We did an activity
Yes, sir.
Yes, sir.
for the flow chart and the pseudocode. Yeah. So for that, the test data, they are called test data, was 7 and 18. Three types of test data. There are three types of test data. Normal, that is one. Abnormal or erroneous, another one. And extreme or boundary. So there are three types of test data. And what are the examples? Let's take the application of a student's exam marks system. What is the normal data? 30, 40, 50, 90, 85. Those things are normal. And what is the expected result? It should be accepted. No? Remember, this is test data for the data entry. Somebody will enter the data. What are the marks? 50, 85. That should be accepted. But abnormalities like -10 or 1000, are they acceptable? No,
No, sir.
be rejected. They should be rejected. And there's a thing called boundary data. Boundary is the end, no, the extreme, no. Boundary is the extreme end of a particular thing. So in the marks scheme, mark students exam mark system, 0 is one end, no, and 100 is the other end, and they should be accepted. Boundary you can take another way also. -1, 101, just outside the boundary. This is inside the boundary, and this is outside the boundary, just outside. Then only you will know exactly the program is working according to your requirement. And those should be rejected, like -1 and 101 should be rejected. Extreme data are the largest and smallest values that normal data can take. Is it understood? The normal data, the extreme is, now in this case, it's 0 and 100. That is what you call the extreme data. That's also boundary, no? That's why I put it here, extreme or boundary. Then validation and verification. These are two methods to ensure any data input to a computer is reasonable and accurate before they are accepted by a program. Two methods to ensure that any data input to a computer, whatever that you input to a computer program into a computer, should be reasonable and accurate before they are accepted by the program. So validation, that method is automatic. The program automatically either accept or reject. Verification is a manual method. So let's learn one by one. First, the validation. Validation is the automated checking by a program that data is reasonable before it is accepted into a computer system. That the data is reasonable. If data entered is unreasonable and therefore rejected, a message should be displayed giving a reason and another chance given to re-enter data. So let's take this one by one. Subtasks like this paragraph, break them into smaller ones. First of all, it says data is reasonable before it is accepted. So why can't it be, instead of reasonable, why can't it be 100% accurate? Validation cannot check errors like you are entering 83 for 38. Maybe a range, later on you will learn. See, range check accepts data within a given range of values. The 0 to 100 is a range, imagine, and the marks are entered. Okay, anything within the range is accepted. But if you enter 83 for 38, does the computer know or the program know that it's wrong? It doesn't know. It doesn't know that it's wrong. It's reasonable and it will be accepted. So that is why it says it cannot detect errors, erroneous data entry you can't. If the operator enters 38 for 83, it can't. But if he enters 101 or 1000 or minus 1, then of course, yes. So it has to be reasonable and acceptable. Then the second one, if data entered is reasonable and therefore rejected, a message should be displayed. So you have to say invalid password or invalid admission number, invalid phone number, or whatever, and also another chance to re-enter that data. All right, and there are certain checks for this. There are checks for this validation. They are called validation checks, and one is range check. First one is range check. That will accept data within a given range of values. The example we did was the marks system. Some, can you think of another system? There are many. There are many.
Like number of students in a class.
Number of
Students in a class.
number of students in a class. Yes, you can say the max. If you uh, have, yeah, maximum is 30. You can't have more than 30, but you can have 20 or whatever. So you can set 30 as the maximum. But then if you enter 25, it will accept. But it's wrong. So there are many, like if you are admitting students above the age of 5 years and less than 18 or something like that, that could be the range. So within that, you can enter and it will accept. So that's a range check. Or maybe the price range. You may have seen on online ordering or that kind of e-commerce sites from $1 to $1,000, $1,000 to $2,000. So you can select your range like that. So then the next one is length check. Exact number of characters. For exact number of characters, for example, password. If it says 8 characters, then 5, 6 will not be accepted. 9, 10 will not be accepted. Only 8 will be accepted. Also, in the length check, you can have a reasonable number of characters. For example, 2 to 30 characters, like name. 2 to 30 characters. So one character will be rejected. 31 or any more characters will be rejected. Then you get the type check. This will check whether the data type is correct. For example, if you are accepting age, if you are waiting for the age and the operator inputs the surname or something, tries to enter the surname, then that should reject, no? That this is numbers, age is numeric, number, integer or something. Then you are entering ABCD, string characters. It should reject. So that's called that check is called the type check.
Excuse me, sir.
Yes.
So can you please like explain again about this data type thinking? Can you give another example?
This last one, the data type, this one.
Yes, sir, the data type.
Yeah. Now I give one example. Can someone else give an example? Try.
So is it like instead of like the data you're supposed to write should be like in like in like a string data type, but then we write it in an integer form. Is it like
Yeah, exactly. If you are expecting like the name, it should be a string or text, no? Alphabetical characters. But if you enter by mistake the age, right? 12 years, 1, 2, the digits, then also it should reject. So that's a type. Data type means, you know the data types? String, character,
strings,
integer,
integers?
huh? Boolean, date,
Sir, what's the
currency.
string? Oh, wait. Ayo. Okay,
Huh?
okay.
Yeah, what's your question?
No, no, sir. I forgot. At first, I forgot the meaning of strings. Sorry, sir.
Ah, okay. So then, anyone else? For the others, okay? Is it understood? Is it clear?
Yes, sir.
Okay.
Okay, sir.
Right. So let's proceed. Character check. There's another check called character check. Hmm? Name. You are doing name. Only characters to come. Only characters meaning like A, B, C, D. No? Yeah. This is similar. Remember, don't confuse with the other one. Phone number, only digits, but not numeric. This also can be a string. Phone number also can be a string, but only digits, no? You get 071 or something, 075. But here, but here name, you don't get 075. No? Samprita 123. You don't get names like that. So only alphabetical characters and the phone number or maybe NIC, National Identity Card number, that kind of thing. Um, it should have some kind of thing to check the digits. And then format check. Next one is format check, which has a particular format. See, CUB9999. So these three may be uh, ABC for another code. This is like a code, no? So ABC 1, 2, 3, 4. But the format. What is the format? First three characters alphabetic. The next four are numeric. Is that clear? That's a format, no? It's a format. Then presence check, that is mandatory where you can't leave it blank. Have you come across things like this on the internet? The email address and all that. You can't leave it blank. Generally, they put an asterisk to indicate that it's mandatory. That means compulsory. Presence. It should be present. That particular data, piece of data should be present. You can't leave it blank. But for phone number, the second phone, that kind of thing, you can leave blank, but not this. When you say the presence check will check whether if you make it mandatory, then it will check. It will reject. If you leave one entry, one box blank and click OK or send message or submit or something, then it will reject. That is on the internet, but if you have a program running, normal on your computer, if there's a program running, then also when you click OK, it will give this message. Missing field. Kindly um, kindly enter the email address and proceed. Then comes check digit. That is the final digit of a code calculated from all other digits in the code. Imagine that there's a code, then the final digit, that's a normally the check digit comes at the end of that full code, and that is calculated by using the other digits of the code. We'll come to that later. At the moment, think of this. How, what does it do? How can you detect errors. And what are the errors detected by a check digit? Firstly, incorrect digit entered. Okay, so the things that can be detected with a check digit, what are they? Incorrect check digit. That means if you have entered 5327 instead of 5307, incorrect digit. You have entered the digit incorrectly, which means instead of 5327, you have entered 5307. This instead of 2, you have entered 0. Okay, then it can detect. Then there is another thing called transposition errors. Transposition errors. That means the digits are okay, but the position is wrong. See, 5037, yeah, 5307. The position is changed. That's a transposition. Omitted or extra digits. So either omitted, in that case 537 instead of 5307, this 0 is omitted, or 53107 instead of 5307, this 1 is extra. Both of them will be detected. Then also phonetic errors. Phonetic means like sounding, no sounding. 13 instead of 30. So if you are listening to something and entering, that mistake can happen, and then that will be rejected or detected because all the digits are taken into calculation. So let's see how the calculation of ISBN 13 takes place. ISBN, do you know what ISBN is?
Yes, and the book they
Yeah. Every
behind the
book
book.
has that, the
Yes.
ISBN, International Standard Book Number. And 13, there are certain things, ISBN or any other check digits. Sometimes the digits are different. So here it's 13.
Excuse me, sir.
Yes.
Sir, will you be posting these notes in
Yes. Yes. I'll be posting this.
thank
At the
you, sir.
moment, it's not there. Uh, so first step, add all the odd numbers, all the odd numbered digits together. All the odd numbered digits together, add them, excluding the check digit. So supposing you have entered 13 digits, or you don't take the 13th one, the 12th. Second step, add all the even numbered digits together and multiply the result by 3. Let's at the same time we'll look at it, then it's easy. Odd number is this: 1, 3, 5, 7, 9, 11. And the even digits: 2, 4, 6, 8, 10, 12. And this is the 13th one is the check digit. So the very first step is what? Add all the odd number digits together, excluding the check digit. So 9 odd numbers, the red ones are 9 plus 8 plus 3 plus 0 plus 8 plus 8. The last two are 8 equals 36. The second step is the even numbers. Add all the even number digits together and multiply the result by 3. So you have to use brackets, remember, otherwise there'll be a problem. So 3 times 7 plus 0, that is this plus this plus this. 7 plus 0 plus 4 plus 9 plus 3 plus 2. Okay, that will give you 75. 7 plus 4, 11, 20, 23, and plus 2, 25. 25 into 3 is 75. Your arithmetic. Okay. Add the results from 1 and 2 together and divide by 10. Add the results from the 1 and 2. So 1 is 36 and this one is 75. So we add up 36 plus 75, how much? 111. So 111 divided by 10 equals 11 and remainder 1. Okay, 10 times 11 is 110, and from 111 there is a remainder of 1. And see the last result. See the last result, last step rather. Take the remainder. If it is 0, use this value. You put 0. If it is 0, the remainder is 0. No more calculation, you just use 0. Otherwise, subtract the remainder from 10 to find the check digit. So in this case, it's 1, remainder is 1. So 10 minus 1 equals 9. And the check digit is 9. So it is correct. Okay? That's how, sorry, yeah, that this is how the check digit is calculated, taking these 12 into consideration.
Excuse me, sir, I have a question.
Yes.
Sir, so the meaning of this ISBN number is like where you find it behind the books, right? Isn't it?
Yes, correct. Last page.
Okay, okay, sir. Okay, sir, thank you.
Usually like that. Places that there's no rule like that, but that's a usual place. All right. So
Okay.
now the next one is to check that an ISBN 13-digit code is correct. Now we have to check that also. No, we have to check whether a certain code is correct. That is when it is entered or scanned, a similar process is followed. Right? What is the process? First, add all your numbered digits together, including the check digit. So no change in the first thing. Oh, sorry, there is one change here, including the check digit. Right? Don't make a mistake there. Including the check digit. Second step, add all the even numbers, even numbered digits, all the even number.
So the first step is saying you have to add all the odd numbers and then even the check digit, right? So
Yes, second one is even. Add all the even number digits together and multiply the result by 3. That's same, no? Then add the results from 1 and 2 together and divide by 10. That's also same. The number is correct if the remainder is 0. See, because we have taken the check digit for a calculation, the remainder should be 0. Oh, let's check. Using the ISBN above 978. That's the same number here. 978 not 3 4 9 right, without this there it didn't have, because 1 2 3 4 5 6 7 8 9 10 11 12 we took that for the calculation without the 13 digits here. 1 2 3 4 5 6 7 8 9 10 11 12 13. That's a check digit. So this time we are taking that also. So adding up 9 8 3 up to this is correct, 8 up to the double 8 plus 9. This time that this 9 is also coming, and that ends up as 45. And this is the same, 3 times the addition of the even numbers. So it's 75. This time 45 plus 75 divided by 10. 45 plus 75 is how much? 100? Too slow.
10.
120. 120 divided by 10 is exactly 12 and remainder is 0. Okay. 10 times 12 is 120. Remainder is 0. So remainder is 0. Therefore, the number is correct. Correct. Right. Then any questions?
No, sir.
Excuse me, sir, can you go a bit up a minute?
Yes.
1 minute. A little more, sir, a little more.
Okay.
A little more, sir, a little more, a
Okay.
little more.
Right. What is your question? You're trying to make a question. Validation, no?
No, okay, sir, no, I
What is
thought
this?
I had one.
Okay. Don't worry, this will be posted. This will be posted on the website. So you can go through it again and then post a question forum. In your forum, you can post sharing the problem, or you can even write to me directly. So in the next session, we'll be doing verification.
Okay, sir.